Video 21. Fine-tuning AI models for business. Script. Most business owners think the only way to use AI is through prompts. You type something into ChatGPT, it gives you a response, and that's it. But here's the thing. Prompting can only take you so far. If you've ever built a customer support bot that keeps going off script, or an email assistant that just doesn't sound like your brand, no matter how detailed your prompt is, you've hit the ceiling of what prompting can do. Today I want to show you what's on the other side of that ceiling. Fine-tuning. Fine-tuning is when you take an existing AI model, GPT-4o, Llama 3, Mistral, and you train it further on your own data, your own examples, your own way of doing things. The result is a model that doesn't just understand your business. It thinks like your business. In this video, I'm going to walk you through exactly when fine-tuning makes sense, how to prepare your data, which tools to use, and what it actually costs. By the end, you'll know whether fine-tuning is right for your business and how to get started. Let's dive in. Let me hit you with some numbers that explain why fine-tuning matters. A well-fine-tuned model can be up to 90% cheaper per request than using a giant general-purpose model with elaborate prompts because you're not burning tokens on multi-paragraph system prompts and few-shot examples. That knowledge is baked into the model weights. Fine-tuned models are 30 to 50% more accurate on domain-specific tasks than prompt-engineered alternatives, because they've learned the patterns from hundreds or thousands of real examples instead of trying to infer them from a handful of examples stuffed into a prompt. They also respond 2 to 3 times faster, because shorter prompts mean less processing. And here's the one that really matters for business. Fine-tuned open-source models like Llama 3 or Mistral running on your own infrastructure can slash your per-token costs by 80 to 95% compared to calling GPT-4o through the API. If you're processing tens of thousands of queries a month, that difference alone can pay for the entire fine-tuning project in under 60 days. Fine-tuning isn't just a technical optimization, it's a business decision with real ROI. So when do you prompt and when do you fine-tune? Let me break this down into 2 columns so it's crystal clear. On the prompting side, prompting is fast to set up, usually taking hours, not days. It works well for general tasks where you just need the model's existing knowledge. It's flexible, you can change your prompt in seconds and immediately see different results. And it requires zero training data. Prompting is your go-to for prototypes, one-off analyses, and tasks where the behavior you want can be described in a few sentences. On the fine-tuning side, fine-tuning takes more upfront investment. You need data, compute time, and evaluation cycles. But the payoff is that the model learns your specific style, your terminology, your edge cases, and your decision-making logic. Fine-tuned models handle the long tail of weird scenarios that no prompt can anticipate. They're more consistent. They don't drift or get confused when the conversation gets complex. And critically, they're much cheaper at scale because you're not paying for thousands of tokens of system prompt on every single request. The rule of thumb I give my clients: if you find yourself writing system prompts that are longer than a paragraph, or you're pasting the same few-shot examples into every request, or you're fighting the model to follow a specific format consistently, you've crossed the line where fine-tuning starts to make sense. Ask yourself 3 questions. 1. Do I have at least 50 to 100 high-quality examples of what I want? 2. Is this task a core part of my business that I'll be running repeatedly? 3. Would improving this model's performance by even 20% meaningfully impact my revenue or customer experience? If you answered yes to all 3, fine-tuning is almost certainly worth it. Let's talk tools. There are 4 main approaches to fine-tuning right now, and I want you to understand the trade-offs of each. First, OpenAI's fine-tuning API. This is the easiest entry point. You upload a JSON-L file with your training examples, click a button or run a single API call, and OpenAI handles all the infrastructure. You can fine-tune GPT-4o and GPT-4o Mini. The downside is cost. You pay for training tokens plus inference, and you can't download the model weights. It lives in OpenAI's cloud. This is great for getting started quickly. Second, Unsloth. This is a free open-source library that makes fine-tuning Llama 3, Mistral, and other open models dramatically faster and more memory efficient. On a single consumer GPU with 24 gigs of VRAM, Unsloth can fine-tune a 7 billion parameter model in a couple of hours. It handles all the low-level optimizations for you: quantization, gradient checkpointing, LoRa adapters, so you don't need a PhD to get good results. Third, Axolotl. This is more of a power user tool, but it's incredibly flexible. Axolotl gives you a YAML config file where you specify every aspect of your training run: dataset format, model architecture, LoRa rank, learning rate, everything. If you need full control over your training pipeline, Axolotl is the tool. Fourth, hosted platforms like Together AI, Fireworks, and Replicate. These let you fine-tune open models on their infrastructure without managing GPUs yourself. You upload data, they train, you get an API endpoint back. It's the middle ground between OpenAI's walled garden and running your own GPUs. Data preparation is where fine-tuning projects live or die. I cannot stress this enough. The quality of your training data determines the quality of your fine-tuned model more than any other single factor. Let me walk you through the exact workflow I use with every client. Step 1. Define your task precisely. Are you building a classifier, a generator, a summarizer, a chatbot? Your data format depends on this. For a chat model, you need conversation-style examples with system, user, and assistant messages. For a classifier, you need input text paired with the correct label. Step 2. Collect real examples from your actual business. Don't make up synthetic data. Go through your support tickets, your sales emails, your customer conversations. Find what your team actually writes and says. That's your ground truth. Step 3. Clean and format. Remove duplicates, fix formatting inconsistencies, ensure every example follows the exact same structure. One stray new line or missing field can confuse the training process. Step 4. Split into train and eval sets. Typically 80% training, 20% evaluation. The eval set is what you use to measure whether your model is actually getting better during training. Step 5. Validate. Run a few examples through your base model manually and check that your expected outputs make sense. If your training data has errors, your fine-tuned model will learn those errors. How much data do you need? For LoRa fine-tuning, which is what most small businesses will use, 100 to 500 high-quality examples is often plenty. I've seen production-grade models trained on as few as 50 examples when the task is narrow and the examples are clean. If you need more generalization, aim for 500 to 2,000 examples. Beyond 5,000, you're usually into diminishing returns unless you're doing full model fine-tuning, which is a whole different ballgame. Let's talk about what actually happens during training and what metrics you should care about. When you kick off a fine-tuning job, the model runs through your training data in cycles called epochs. Each epoch, it sees every example once and adjusts its internal weights to get better at predicting the right output. The key metric to watch is training loss. It should steadily decrease, meaning the model is learning. But the metric that really matters is evaluation loss on your held-out eval set. If training loss keeps dropping, but eval loss starts going up, you're overfitting. The model is memorizing your training examples instead of learning generalizable patterns. For a typical LoRa fine-tune on a 7 billion parameter model with 200 examples, expect training to take 30 to 90 minutes on a single A100 GPU, or 2 to 4 hours on an RTX 3090 or 4090. Cost-wise, if you're using a cloud GPU like RunPod or Lambda Labs, you're looking at $1 to $5 for the entire training run. If you're using OpenAI's fine-tuning API, a small dataset of a few hundred examples might cost $10 to $50 to train. The real cost isn't training, it's inference at scale, and that's where open models shine. A fine-tuned Llama 3 8B running on Grok or Together AI can serve responses for 0.05 to $0.10 per $1 million tokens, compared to $5 to $15 per $1 million tokens for GPT-4o. At 100,000 queries a month, that's the difference between a $50 bill and a $5,000 bill. Once your model is trained, you need to decide where it lives. This is a two-column decision. On the local side, running the model on your own hardware or a dedicated cloud GPU instance gives you complete control, zero per-request costs beyond electricity or instance fees, and total data privacy. Nothing leaves your infrastructure. This is ideal for businesses handling sensitive customer data, healthcare information, or proprietary internal processes. The trade-off is you need to manage the infrastructure. Tools like Ollama, VLLM, and Local AI make this much easier than it used to be. You can spin up a model server with a single command, but you still need to monitor uptime, handle scaling, and deal with GPU availability. On the hosted side, platforms like Together AI, Fireworks, Grok, and Replicate give you an API endpoint that works just like OpenAI's API, but serves your fine-tuned model. You pay per token, you don't manage any servers, and you can scale from 0 to thousands of concurrent requests automatically. The trade-off is cost at high volume and slightly less control. For most small businesses, I recommend starting hosted while you validate that the fine-tuned model is performing well, then considering local deployment when your volume justifies it. A hybrid approach also works well. Fine-tune a small, fast model for high-volume tasks and keep the big general-purpose model for complex edge cases. Use the right tool for each job. I've fine-tuned dozens of models for clients, and I've made every mistake in the book. Let me save you the time and money. Mistake 1. Training on garbage data. If your training examples are inconsistent, poorly formatted, or simply wrong, your fine-tuned model will be worse than the base model. Garbage in, garbage out applies tenfold here. Mistake 2. Skipping the eval set. Without a held-out evaluation set, you have no idea whether your model is learning or memorizing. Never skip this. Mistake 3. Training too long. More epochs is not better. Overfitting makes your model brittle. It performs beautifully on your training examples and fails on anything slightly different. Watch your eval loss and stop when it plateaus. Mistake 4. Not testing on real-world inputs. Your eval set isn't enough. Put your fine-tuned model in front of actual users, or run it on a backlog of real production data and compare its outputs to what a human would have done. Mistake 5. Fine-tuning for something prompting could handle. If a 2-paragraph system prompt gets you 95% of the way there, fine-tuning is overkill. Only fine-tune when prompting consistently fails. Mistake 6. Ignoring cost at scale. That fine-tuned model that costs pennies per request during testing might cost thousands when you deploy to production. Do the math before you commit. Mistake 7. Not versioning your models. Every time you retrain, save the old model with a version number and a note about what changed. When something breaks, and it will, you need to be able to roll back. Here's exactly how I'd approach a fine-tuning project over 30 days. Week 1. Define the task and collect data. Don't touch a GPU yet. Spend the entire week gathering real examples from your business, cleaning them and formatting them into a consistent dataset. Week 2. Baseline and train. Run your base model on the eval set so you have a benchmark. Then run your first fine-tuning experiment. Start with default hyperparameters. Don't try to optimize everything at once. Week 3. Evaluate and iterate. Test your fine-tuned model against the baseline. Identify where it's still failing and collect more targeted training examples for those failure cases. Run a second fine-tuning round with the expanded dataset. Week 4. Deploy and monitor. Ship the model to a staging environment. Run it on live traffic in shadow mode, where it generates responses but a human still reviews them. Then cut over to production once you're confident. Set up monitoring on accuracy, latency, and cost, and schedule a monthly retraining cadence to keep the model aligned as your business evolves. Fine-tuning is the most underutilized capability in business AI right now, and it's not because it's hard, it's because most people don't know it's an option. The tools have gotten dramatically better in the last 12 months. Unsloth makes it so easy that you can go from never having fine-tuned anything to having a working custom model in a single afternoon. The cost barrier has essentially disappeared. You can train a model for less than the price of lunch. Here's my challenge to you. Go find one task in your business that you've been fighting with prompts. Maybe it's classifying support tickets. Maybe it's generating responses in your brand voice. Maybe it's extracting structured data from messy documents. Collect 100 examples of the input and the ideal output. Spend an hour cleaning them up, then spend $5 training a model on Unsloth or Together AI. Compare the fine-tuned model against your best prompt. I think you will be shocked at the difference. Fine-tuning turns AI from a general-purpose assistant into a precision tool built for your specific business. And once you've experienced that, you'll never look at prompting the same way again. Thanks for watching. I'll see you in the next one.